Hello, we're going to be talking about the chemistry of alkanes now. Now, we'll be talking about the formation of alkanes and the reactions of alkanes. First and foremost, the first way we can get alkanes is by adding a heated soda lime mixture into carboxylic acid and its derivatives. Basically, what happens is that the carboxylic acid or derivative group gets replaced with a hydrogen and we get an alkane. So that is very technically unsound, but at the end of the day, that is what happens. If we have an alkyne or an alkene, we can add hydrogen and heat it with a catalyst like nickel, platinum, or palladium, and we will get the respective alkane. Or if we imagine we have a carbonyl compound like an aldehyde or a ketone, we can put it through something called Clemmensen reduction. Basically, by adding zinc amalgam and concentrated hydrochloric acid, we can get the respective alkane that can be produced from the said carbonyl compound. There is this thing called the Wurtz reaction. Basically, we can take two alkyl halides and we react them with sodium and ether, and we will get the resultant alkane. In this case, it will be a propane. Or another way of doing basically this thing is that we can take an alkyl halide and mix it with a Grignard reagent, and it will form an alkane and magnesium halide. So here we have methyl bromide. We react it with methyl magnesium chloride and we get ethane alongside MgBrCl. And that's another way of producing alkanes. This thing is a bit hectic and boring, so we'll keep it for last. We'll go to the reactions of alkanes. Basically, if we have any alkane, we can react it with oxygen to form carbon dioxide and water. This is combustion. It happens at high temperatures. And these are the stoichiometric coefficients in terms of the number of carbons and hydrogens present in the hydrocarbon. And this, my friend, is what we call free radical chlorination. It is done with chlorine and an alkane under diffused sunlight, and it produces alkyl halides as following. Mostly it produces a monosubstituted one, but disubstituted, trisubstituted, and tetrasubstituted ones might form in decreasing numbers. And these are the reactions of alkanes, not many. And now we will go back to these hectic reactions, absolute maniacal reactions. What we do is we take a Grignard reagent and we hydrolyze it, and when we hydrolyze it, what happens is we form an alkane and these hideous compounds that don't deserve to be in this earth. Basically, I don't know why someone would do this. You have a beautiful Grignard reagent which is very useful, and you absolutely ruin it to get a petty alkene and these absolutely hideous monsters. Anyway, what happens is basically the R group of these compounds, they borrow a H from these compounds to form the alkane, while the remaining products they mix together to form these hideous monsters. I'll take an example. For example, here R borrows a H from water to form RH, while the remaining OH and MgX of this group will form MgXOH. Right? Okay, so far so good. Now, what if we react? What if we degenerate? What if we dissolute? What if we were to basically ruin this Grignard reagent with a primary alcohol? What happens is the R, it borrows an H from this group and forms RH, and the rest hook up and form this hideous son of a bitch. Basically, the R and the O mix with the MgX and forms R-OMgX. Here, R and H, they form a nice decent alkane, and R dash C double O and MGX. They mate and form this hideous motherfucker, which is R dash C double O MGX. You can probably get the trend by now. You see MGX and N R dash NH will remain to form this person, while the R and one of the H's form RH. I think you can generalize it for the last three, but we'll do it anyway. Here we have an R group. R group will react with the secondary amine, and the H and the R will form RH, while R2 dash while this R2 R dash N and MGX will form this twat. R will react with, if here we have an alkyne. R will react with H to form RH, while R dash C triple bond C MG X will react to form this cunt R dash C triple bond C MgX. Here we have a Grignard reagent and an alkyl halide. Basically what happens is, this time it's a different formula. It doesn't happen like this. The R and the R dash combined, while the Mg will have the two halogen groups. And that, my friend, is the chemistry of alkanes.